Okay, so for question 18a, they given us an equation y equals to 2 to the power of x squared. So 2 to the power of x squared, so this is our exponential function because x is in power, like e to the power of x. So this question like e to the power of x squared, so exponential function. So question A, when y equals to 2 to the power of x squared, find its first derivative, find its differentiation, the first differentiation. So we differentiate y with respect to x. So for exponential function, salin soalan, differentiate power dia. So look at the power. Our power here will be x squared. So we're going to differentiate x squared inside here will become 2x power turun depan, power tolak 1. So this is our exponential rule. Salin soalan differentiate power dia. So because our exponential base is not e, is our number of 2 is an indices. So therefore we still have one more step, which is time with the base ln 2. So this is our full differentiation. Okay, salin soalan differentiate power ln to the base. So ln to the base 2 here. So this is our fully differentiation. So if I want to rearrange them, so I can write it the constant. So ln 2 is our constant. So 2x is our linear times exponential function. So nothing we can multiply. Okay, nothing we can multiply because ln 2 actually is a decimal. So ln 2 we cannot multiply, become ln 4. Cannot. Because ln 4x we cannot multiply like that. So ln 2 is a decimal actually. So if we decimal it and we times 2, then it's okay. So if we become ln 4, then it's not okay. We cannot multiply like that. So we will just let our answer like this. So that will be our first differentiation, first question on A. And then for question B. So question B, they ask us to show these equations. So look at our question B here. When we want to show this equation, we need our first derivative. And then at the same time also we need our second derivative. So from here, what can we do is we take out our questions. So for question B, our question is y equals to exponential ex. So time ln. So we have two functions multiplied together. One of the function x is exponential, another function x is ln x. So when we have two functions multiplied together, we will use product rule. So when you want to differentiate y with respect to x, we will use product rules. So how's product rule goes? What's the rules of product rule? Salin yang depan, differentiate yang belakang. So we set up our product rule. Then plus salin yang belakang, then differentiate yang depan. So this is what we salin yang belakang, then we're going to differentiate yang depan. So this is our product rule. Okay. So salin depan, differentiate belakang. Salin belakang, differentiate depan. So we set out our product rule. Then we're going to differentiate the part that we want. So when you want to differentiate yang belakang, when we look at belakang function here, it's a ln function. So when it is a ln function, to differentiate ln, okay, to differentiate ln, the rules will be salin isi pelut ln. So isi pelut ln is 1 plus x. Differentiate it at here, at numerator part. So differentiate 1, we get 0. Differentiate x, we get coefficient 1. So it will become answer 1 over 1 plus x. So this is how we differentiate ln. And then at the back here, we want to differentiate ex. So if you want to differentiate ex, like just now, salin soalan, differentiate power there. So power x, when we differentiate, we get 1. Then ln to the base e. When we have ln e, we get 1. So exponential just salin soalan differentiate power. So when we have exponential is not base e, then we have one more step. We have to multiply with ln 2. So after we finish our first derivative, product rule here, we try to simplify. So we're going to try to simplify. We can notice that here we have same factor. We have factor ex. So here we have another factor ex. So we can factorize it. So if you look at these questions, we can factorize it. Either we can do substitution method where we factorize it, okay, we factorize it, and then we find another second derivative test, and then we do substitution, substitute our dy dx, substitute our d2y dx squared. But for here, we can see this, we can modify. So actually this question we can straight away, we modify in order to get this equation straight away. Because why we can see modification occur, because we can see exponential ln 1 plus x. This is our y. So we can modify it become y. So later on we want to differentiate, it will be more easier. So we will continue. We will maintain like this. So dy dx will be equals to ex. So this part will become 1 plus x power of negative 1. And then this will plus y. So when you want to differentiate it again respect to x, what we can do, so dy dx, when you differentiate it, it will become d2y dx squared. So obviously we obtain this symptom already, this symbol already. So in the middle part here, we have exponential function, we have rational function. So two functions together again, multiply together. So again, we are going to apply our product rule. So product rule say that salin yang depan differentiate yang belakang. Then tambah salin yang belakang differentiate depan. So differentiate the part that we want. Differentiate yang belakang. So when you look at our belakang here, this is in the power, a bracket or a power. So we can use our power rule. Power turun depan. Power tolak 1, differentiate dalam kurungan, tinggal 1 saja. So, salin yang belakang, differentiate yang depan, differentiate ex, salin soalan, differentiate x, dapat 1 balik. So, dapat ex balik. Then I continue another part here for y. When I differentiate y, I can get dy dx. So you can notice that this term I also obtain. We obtain d2y, we obtain dy dx. So just need to modify here in order to get this pattern. We can get this pattern. So we will move this dy dx to the left hand side so that we can get this minus dy dx. So modify one by one. Means we are going to rearrange one by one. So for this, negative 1 times 1 of course will give us negative ex. And then power negative 2, it will be go down as denominator square. Power negative 2 go down as denominator square. So for that part, plus ex over, so 1 plus x. So what else we can see what we need to obtain? We need to multiply this by x plus 1 square. So x plus 1, 1 plus x, actually they are the same things. But if x minus 1, 1 minus x, it will be different because minus a minus b, b minus a, the difference. If plus together, a plus b, b plus a, they are same thing. So for this equation, we're going to multiply with x plus 1 square. So once we multiply with x plus 1 square, you can notice that we managed to obtain our left hand side. So this part also we obtain already. So when I multiply this x plus 1 square, so this denominator is cancelled, leaving a negative ex. So for this part, it will be ex times 1 plus x, because it's times with x squared, they only cancel 1 plus x at denominator. So we look at our answer here, what should we need to do? So we need to simplify this until we get x ex. So we're going to expand. When ex times 1, we get ex. So we get ex times x, we get xex. So notice that here, you can kindly refer here, minus and plus, our exponential can be simplified. Therefore, finally, we're going to prove this. These equations, so shown.